Alright, just a quick video on function notation. Okay, so we're using f of x now to replace y, and we're doing that whenever we are working with a function. So we know functions are, for example, quadratic functions, because for every value of x, there's only one value of y. So we could represent, instead of saying y equals, we can now say f of x. So the way to pronounce this is just f of x. That's how we say that. So then we can also use this notation if we wanted to sub values in for x. So let's say we wanted to find f of 2. So that's just saying for this function we want to know what the y value will equal when x equals 2. So we'll sub a 2 in and we'll figure out what that equals. So we got 12 because 2 squared would be 4. And 4 times 3 would be 12, plus 4 minus 5, which would equal 11. So now we know this is just saying f of 2 equals 11. And what's that saying is when x equals 2, y equals 11. Or you can write it as a coordinate, 2, 11. So that's what that's saying. And you can use this notation to represent any functions. So let's say we had f of x equals 2 root x plus 1 minus 6. Then we can sub values in to this also. If we wanted to find out, hey, what's f of 3? Then we could sub a 3 in for x, 3 plus 1 minus 6. Or another way to say that is 3 comma negative 2. And we could also use this notation the other way. So if I gave you an equation like f of x equals 3x plus 1, find f of x, or actually, wait, I should say that in a different way. I could say f of x is equal to, say, 10. Find x. Okay, so now I know f of x is equal to 10, so I can set that equal to 10, 3x plus 1, and now I'm just trying to isolate x. So I'll move the 1 over, so I get 9, divide by 3, and I get x equals 3. Alright, and that's function notation.